Hello again and welcome back to Garage Science. Well, this puppy is the newest toy. So right now I'm facing off some 2x4 to work on a kid's project. So a little overkill for a little bit of wood milling, but you know, why not? So this video is basically going to kind of cover some of the high points and low points of things that I broke and things that I actually got right while I was setting this up. So it's not a step-by-step guide by any means. Certainly refer to the Tormach videos for step-by-step guides on specific pieces parts. But this was the package that included the enclosure, the stand, the tool changer for the PCNC440, and this is my first actual milling machine. So I think this was a nice size to get started with. Gonna mostly be milling aluminum with this. And so yeah, more to come, but let me know what you think of the video and stick around because I got some things that I learned and things that you're definitely gonna want to avoid if you're taking on a project like this. All right, let's get started. All right, so here's the mill with the tool changer installed and the power drawbar up top. See it poking out of the top there. I'm gonna do a walk around real quick before I put the flood coolant and the enclosure on, just because there's a few things I want to talk about. But the tool changer works. Go ahead and put this guy away. But I had to reference the tool tray before I moved in. So that took about 8 hours yesterday to get that set up. Most of that was spent getting all the alignments and making sure it was perfectly square. There is a few things I want to talk about with the tool tray. And Tormach, if you're watching, then take notes. So basically, this cutout right here for the tools is really tight around the spindle, I don't know what you call this, like the frame, the main column here, right? And so getting that fully centered on there is really difficult. So what I would recommend is make sure that when you are getting this mounted, and I actually found out it helped to, once you get it close, to put a TTS adapter in the tool tray and get it to go into the spindle, right? And then hit your e-stop so that way you don't accidentally move the machine, right? And then get this so that way it's nice and stable wherever it is, right? And tighten all your screws down, so that kind of guarantees that your location is legit. So that's only something you can do once you're close. And then something else I had to deal with was the video where they show installing this never talks about the pneumatic actuator. I gotta actually dig back through the documentation. I don't remember seeing this mentioned actually for installation either. Maybe it is. Maybe I wasn't paying attention. But yeah, I basically went to go use my my ATC first and plugged in the air, and there's air spitting out of these the lines because I hadn't put in the pneumatic actuator. So make sure you install that. And then just because they don't cover it in the Tormach video, the forward port, right, this guy goes to the right bottom air port, and then the retract port goes to the left bottom air port. So just a little tidbit there. And then kind of the last thing, a little bit of a gripe that I have, because after spending hours trying to get the alignment right, I kind of rethought how I was doing this, because I realized, because this cut is so small, the travel on the ATC was such that I was kind of always ending up hitting the back side of this cutout by the time I got everything else aligned. And so whenever I tried to move the main column Z down, it would catch, and of course I don't want that to happen every single time I use the tool tray. So what I ended up having to do was put washers on the back of here, because they have an adjustment nut here, right? It's a lock nut kind of design here, and that's supposed to allow you to change the travel distance, right? But it's bottomed out, and I can't bring it this way any further, right? And you can see there's basically no gap there. The only gap that's there is because I put washers here to shift the entire actuation assembly to the left. So shorten this rod maybe about 3 to 5 millimeters, and the rest of us will be very happy for it. And then just one more quick note. I had at one point, when I was installing this, I had to deal with the electrical like 3 different times, because after I messed with my air ports up here on the power drawbar, I just half closed the door like that and did all my other connections. And then when I went to go do the VFD check to make sure my spindle still worked and communicated with the ATC, the spindle would never turn on. It would never turn on. I redid the electrical connections probably 5 times, they never turned on. And so the problem is this limit switch up here will not allow you to turn the spindle on unless this door is shut, which makes sense because there's a belt in there that's moving pretty quick. So, you know, just do things the right way. That's the big takeaway. But ATC works no problem. So next step will be flood coolant and enclosure. Okay, so the flood coolant's installed. So this is basically the return path. Got the coverage right there. Comes down here, right, and goes to a hose around the side, down into the cabinet, down into the flood coolant tank. Got the submersible pump here with the injection line, the output for the pump there. Comes up over here. And had to come up with an alternate mounting location because the mounting location per the tech docs is supposed to go right here, but that conflicts with the movement of the ATC, and it actually doesn't fit with the guide bar here. So yeah, and don't know why they didn't put an alternate mounting location in the documentation, but I got it mounted there. One thing I got kind of hung up on when I started was I kind of thought this was like an auxiliary plug for your power strip to run your computer and controller and everything. What that actually is the plug for your coolant pump. So this is the power plug for the pump, and then so that'll go directly into there, and you can turn it on from the controller, either in your G code or manually. One more step down. Flood coolant system is running. Got a couple of drips coming out of there, but really care less. Once the enclosure is on here, there will be coolant going everywhere. So pretty good pool of coolant circling around here, so I'll go down the drain. I did put a piece of wood up in there just to kind of make sure everything is draining down. You don't get high spots at all. Helps it drain below the level of the pan. And down here, and the coolant bucket. So I did end up needing to do about 5 gallons of, probably about 4, yeah, it's probably close to 4 gallons of water at a 20-to-1 ratio with the Qualichem cutting oil that Tormach sells. So it's works pretty good. I got plenty of the cutting oil left, so it should last for a good long time. But it's all pretty quiet. I mean, the loudest part is the water splashing around up here, and the motor's humming along. Path pilot works just fine, and turning it on and off. Yeah, very good, very nice. Next, the enclosure. All right, so I'm working on getting the enclosure fixed up and installed, and I just wanted to cover something real quick. So these holes on the side of the front of the frame, they are they're not quite far enough forward for the hinges to close, where the door actually sits on the side of the enclosure. And so what I had to do is actually drill these out to enlarge them, so that way the hinge could sit further forward. Also, these hinges, they're not made by Tormach, but the screws, the countersunk screws that they send with, they don't fit all the way down in the countersinks for the holes in the hinge, and the holes in the hinge were also too small for these screws, so they had to get drilled out as well. So not like a huge deal. The door closes just fine. There's like tiny bit of flex, and well, it's probably from the plastic that's all on that side, but basically I want the doors to be able to open up and sit flat on the front, so no one can just like push on it and potentially crack the acrylic. So other than that, it's gone together pretty good. Haven't had really any major issues. So yeah, more to come. Well, that sucks. Got my coolant hose pinched between the way oil connection on the Z-axis on the way back up, and yeah, make sure your coolant hose gets routed under here, so that way the up and down motion is completely free of all of your way oil lines. That was extremely poor thinking on my part. So thankfully I was able to crimp that back to the point coolant still flows through it, but it was pretty much pinched completely shut, and I just have to buy a new brass fitting for that. And +1 for having the speed out tool to get rid of sheared bolts, get sheared bolts out of holes. So that made getting this out pretty easy, but unfortunately I'm gonna buy another fitting. So kind of a crisis, but not a super big crisis. All right, so I went ahead and played around with this morning. I basically soldered it back together. Looking around online, it's actually kind of hard to find this fitting. It's 5/16 by 24 female and male threads, so they're both the same. So it's kind of like just a standoff, and couldn't find it in any of the hardware store websites, and couldn't even really find it on McMaster. So maybe they have it, but I couldn't find it. So I went ahead and tried to repair it. I think it'll work. This is not a high pressure system, so so long as I don't crash the mill into it, I think it'll be just fine. All right, so something I did with the door here is after I ran it with the coolant for a little bit, the door was getting underneath the lip. It was getting coolant, and because coolant has kind of like a milky white kind of color to it, you could see it in there. It's kind of obstructing the view. It's a little annoying. So I took it off, put silicone under there. It's white and dries clear, so probably take a little while for that to cure since it's squished in there, but that should prevent any coolant from getting between the left door lip and the left door. I'm working on printing something right now on the 3D printer for the coolant hose. The instructions for the installation didn't specify where to mount your coolant hose at, and there's not really a whole lot of places to mount it. So there's actually 6mm screws under here. There's one there, there's one there, and then some on the other side. So I had some 6mm screws on hand to bolt in the coolant pump, because sorry, not the coolant pump, the coolant hose mount, because it doesn't fit on the other side with the ATC installed. And so so what I'm gonna do though is, because this guy's still kind of in the way, then I'm going to basically mount like a little bracket here that loosely allows the coolant hose to slide up and down in it, just so it kind of stays pushed towards the back. And then as the so the coolant hose will get kind of held towards the back, and then as the ATC moves back and forth, it'll be able to easily push it out of the way. So that's kind of my big concern, is like if the hose, I don't know, like between all the movements, if it comes, maybe all the way out here, and then maybe your ATC moves over and then rotates to a longer drill bit and then like catches it, and then it all gets sucked up, and then the drill bit's gonna like grind against this or pinch it in between that and the part, and that's just dangly stuff like that in a rotating machine's never good. So I'm gonna kind of create a path for it to move up and down on the back wall of the enclosure, so it stays out of the way. But yeah, that's what we're doing next. Alright, so I'm working on setting up a wooden table for the wood stuff that I want to practice milling on. This morning I actually mounted the guide for the coolant hose, so that's on the back now. So 3D printed that yesterday, mounted it this morning. It allows the hose to freely move back and forth there, but make sure that it stays out of the way of the automatic tool changer. What I just noticed this morning is basically what I wanted to do was do like a very shallow outline with the 1/8 inch end mill, and just do like what the XY work area looks like, just to have a visual representation when you're setting up parts and everything. And it turns out the X0Y0 position is off table. I didn't realize that till just now. So my board needs to get bigger to actually encompass the entire work area. But the max travel, right, when you go to X0Y0 is off table. So that's a little tidbit, not world ending by any means. All right, so this is the new fixture plate. I actually extended it off of the table forward on the front end because as I thought of extending it off the back end, I realized there's a pretty significant portion that will fit between the casing and the table on the front end as well. So measured that out. It's about 7 to 8 inches. So made the table extend off the front of the table by about 7 inches. So, and then it runs up to the cover for the back gantry, pretty much right up against it. So I've definitely maximized this space. I'll go ahead and move this around. So going to the Y0 position. So I got a little gap there. Got some vertical clearance there, depending on how big the part is that may be sitting on the table. And then the Z. So you can see there how close it is to the edge of the wood, and that edge of the wood is the bellows, right? So like the maximization of space for this mill is actually pretty good. Like you get full use of the XY cutting area that is possible on a footprint this small. So I wasn't really thinking it would be that close, so I kind of winged it. But yeah, anyways, should work out pretty nice. And so then we're going to go to the Max X. And so what this will end up doing is just producing an outline on my fixture plate, so I have a visual representation when I'm setting something up of where the cutting area is able to be, so that way I make sure I get the orientations right and the locations right. But all this is being done right now with the jog shuttle and Path Pilot. So, and you can actually see the work area there on the screen, and how I'm just tracing out the edge of it. I could probably go faster than this, but I got time. There you go. So now you can kind of get an idea what the XY footprint looks like on this machine. It's 6 inches by 10 inches. You know, not a bad work area. So something I'll probably be fooling around with is if you get your fixturing right, it's probably possible to mill larger parts than just, you know, what can fit in this square area. It's just, you can only do work on this amount of the part at a time. So if you get your fixturing right, then you could presumably have larger parts that you know, go beyond the borders of the machine movement area, and then you just would have to reorient the part multiple times to fully machine it. But, you know, that'll be a good experiment for another day. Well, my tabs weren't strong enough to hold the part in place. I think it broke mostly on the edge. It was a little close, so I didn't have much stock remaining to hold the tab in place. So let's see if the second one survives any better. So I was a little too aggressive with my end mill there, taking about I think I set it to about 10 millimeter cut depth, but not so much, too much for the mill head, too much for the wood, and it actually pulled it up out of the holes that I had it tapped and screwed into. So we'll prepare another stock and probably change that cut depth to maybe about maybe 3 or 4 millimeters. Yeah, that's a good lesson learned, and I'll probably change my tab options, since my first one kind of broke out of place before it finished. But that might also get fixed by changing the cut depth so it's not quite so aggressive. So we're just about finishing up with a 3/8 inch end mill on these train pieces. I did gouge a section off there. I set the entry to be a spiral type entry, and oops, probably shouldn't have done that on a perimeter feature. So lesson learned. I don't know why it only did it there instead of everywhere else. So we're just about done. Should see a tool change here in just a second. Here in about a couple seconds, you'll see a tool change. Yep. There we go. And on the E-stop button, just in case. Change the current tool. Go to the 8 inch end mill. Boom. Look at that. That is a thing of beauty. Well, that wasn't a thing of beauty. That was deep. Holy cow. That should not have been that deep. I gotta take a look at that. Dang, that was like half the depth of the machine, or the that end mill. Alright, so we're up and running again. So basically what I figured out is that the tool offset for my 3/8 inch end mill, which is what I set the Z with while it was chucked up in there, is I fat fingered the tool offset. So it cut everything with the 3/8 inch end mill properly, because I set the Z with that tool, but the tool offset was off. So the 0 basically for the next tool, or all the other tools, was incorrect, and that just messed me up. So unfortunately that resulted in some gouging in the left part, and then because I had the cutter compensation set on in SolidWorks cam, it generated an awkward tool path that caused gouging in the right part. So the bolt won't be perfect, but you know, it's still a good test. Should actually have another tool change here soon. Now we're about to finish here. We're going to have another tool change. We'll do the cam first to finish up. Trimming up the edge, kind of cuts the burrs off and gets rid of the sharp corner. That's a Dremel tool, by the way. No need to always have fancy, ultra fancy carbide milling tools, especially when you're working on a machine this small. That's it. All right. So a couple things to see here. One, gouge the part there on the corner. So you can see the corner's missing there. That's because I had an awkward tool path that I didn't notice when I brought it into Path Pilot. I believe that's related to, I had the cutter compensation turned on for the 3/8 inch end mill that was doing the outline initially, and so I think Path Pilot didn't play nice with that setting from SolidWorks cam, and so it generated almost like a spiral little feed-in on a one of the lower passes for the outline on this part. Not entirely sure why that only occurred once in the tool path, but anyways, definitely didn't show up in the simulation. And then so I turned that off after I crashed over here, so you can see there's a depth. It's about 4 millimeters too deep on the first pass on this side, and that was because the 3/8 inch end mill, I fat fingered the tool offset in Tormach, and so so when I set 0 while the 3/8 inch end mill was chucked up in the mill head, it basically set Z0 to be too low, and so then when it went to the 1/8 inch end mill, it went way too deep on that guy. So I changed the tool offset, I changed the cutter compensation, and then reposted it. And so what you see now is there's kind of an outline of unremoved material, and that's because of the cutter compensation that I turned off on the 3/8 inch end mill. So because I turned it off when I went to the 1/8 inch end mill to do the outline perimeter of the part, it was doing a full diameter cut basically while I was doing that, because the cutter compensation was on in the SolidWorks cam when it did the rough outline with the 3/8 inch end mill. But you know, it's gonna be a work in progress. Glad that wood is, you know, relatively cheap these days, a little cheaper than aluminum, but maybe that won't be the case for much longer. But this was a good test piece, so certainly learned a lot in the process of doing all this, and eventually I'll be milling away at all kinds of exotic materials. Not really, because this mill is only 3/4 of a horsepower, but can still do quite a bit. So alright guys, so that's it. You know, I didn't do this as like a step-by-step setup because a lot of this is just work. There's also plenty of things that have happened off camera where I've been just finagling and fiddling with this thing and trying to get it all to work. This is by no means a fast process. A machine like this has many details associated with it. And so, but I'm pretty satisfied. And Tormach's been extremely helpful. Had some equipment that got damaged during shipping, and they replaced it without question. And they've just been super helpful in the setup. So major shout out to the support team over at Tormach with Norm and Craig and Katie. All you guys really helped me get up and running. So thanks, guys. And then yeah, you know, I'm gonna learn more and more about this machine every day. A few things that I've kind of done on my own, right? So like this guy here. I think earlier I mentioned that there's no place to mount this. Looking around on the Tormach site, they actually do sell a bracket that essentially establishes the same mounting holes that are on this side. On this side, there's an angle bracket you can buy that screws in right here. It's like 30 bucks. So Tormach, you know, when you sell this kit, when you know people are going to use the tool changer, just include that bracket. You know, probably cost you like $5 to make that, and makes things a lot easier for us. But anyways, got it working. I kind of like having the valve in the front like this, so I can see the position of it from the front of the machine. But you know, to each his own. It's not bad. And you know, I've got some ideas on different projects, and I certainly plan to make the most out of this mill. So yeah, can't wait. And if you guys enjoyed watching this, then make sure you subscribe and hit the notification bell, and you know, check out the other videos, because this is the first video on something like this, but there'll be more to come. You know, I do want to start posting videos more often, and appreciate all the support from viewers. And yeah, you know, can't wait. It's gonna be awesome.